So we've looked at polynomials, and now we want to look at rational expressions. So a rational expression in X is just a ratio of two polynomials, kind of simple. So it's, I'll say px divided by qx. This will be my notation for it. So these are both polynomial expressions in X. And of course, for this to make sense, we're going to have qx not equal to 0, because you can't divide through by 0. So just some quick examples. We could have (1 plus 2x plus x squared), quadratic divided by linear, 3x plus 1. That's a rational expression. We could also have something like this: 2x squared plus 1 divided by 1. Okay, there's nothing wrong with that. 1 is a constant polynomial, 2x squared plus 1 is a quadratic polynomial. But this, of course, is just a polynomial at the end of the day. So moral of the story is polynomials are rational expressions as well. It's kind of like saying that the number 3 is a whole number, but you can also think about it as a fraction because it's 3 divided by 1. Okay, so algebra with rational expressions is very important, or being able to do algebra efficiently and precisely with rational expressions, as I said, is very important. It is going to be something that you can do an awful lot of in your early calculus classes. And the main thing about this is the following, I would say. Just as a general piece of advice about how to approach these types of things. This is really true of all mathematics, but it's especially true of this. When you're doing algebra with rational expressions, be very slow and be very, very systematic. So don't try and jump steps. Make sure everything is done just in a completely kind of calm, methodical way. So keep every step simple. Keep every step simple and don't skip any. It's not a competition to see how incredibly quickly someone can go through various algebraic steps. It's basically doing it correctly. It's much more important that you can do it slowly and correctly above anything else. So what I really want to do is just do some examples to illustrate the type of algebra you'll be doing with rational expressions. So let's start off with the following. So let's find polynomials. Let's say px and qx such that the following is true. So x plus 1 divided by x squared minus 1 plus x to the power 3 minus 2 divided by x squared plus x plus 1 is equal to this px over qx. So really all I'm asking here is to take the left-hand side and combine everything into one expression and then make sure that you write it as a polynomial divided by a polynomial. So let's go through this incredibly carefully. This is the kind of thing that you'll be doing a lot of, and you've got to make sure you can do it without making mistakes. So this is what we've got to deal with. We've got to somehow simplify this. So of course, we know from my basic laws of algebra how to deal with the sum of two fractions. So the sum of two fractions, well, what's it going to be? So let me just take a moment to think about this. If I take the sum of two fractions, let's say a over b plus c over d, what's it equal to? Well, let me do it first like this. This is equal to a d divided by bd plus bc divided by bd. That's kind of the first step in doing the sum. So let's do that, shall we? Like the denominator's the same. So this is equal to, okay, so it would be x plus 1, x squared plus x plus 1. Okay, I'm going to have to deal with that. All divided by the product, x squared minus 1, x squared plus x plus 1. And then plus what? It's going to be plus, so it's going to be x cubed minus 2, x squared minus 1, divided by, same deal again, x squared minus 1. So I've written the top one backwards, it doesn't make any difference. A times b is b times a. Okay, so now at this point we can combine things together. So now the denominators are the same. And what do I know about that? Well, I know if I have two sums, so I'm going to really just labour everything here. If I have a over b plus c over b, that's equal to a plus c over b. So when you're doing these, you don't need to write all of these little comments, but it's very good practice to do it at least once so that you can really, really hone in on the core things you're using at every stage. So at this point, what have you got? Well, you're going to have this first term plus the second term all divided by just the base, by the denominator. So now what have we got to do? Well, we've got several ways of doing things, but what we essentially need to do is to multiply everything out and combine them. So something I will say is quite often it's a good plan to keep the denominator factored. It's not always the case. I'm not going to do it here, but it's common to leave it factored. There's no real problem with it, but it could be useful. So don't think you always have to multiply out the denominator. You'll see, because sometimes having a factored denominator could be really useful, to leave denominator factored. Right, not always the case. And I'm not going to do it here. I'm going to multiply everything out. So goodness gracious me, we've got to do the top now. So now I've got to multiply the first two. That's going to be standard distributive law. So it's going to be x cubed plus x squared plus x. That's x times the second piece. Then it's going to be plus 1 times the second piece. Then I'm going to FOIL over here. So this would be x to the 5, x cubed times x squared. And the outer, it would be minus x to the 3. And the inner, minus 2x squared. And then the last, minus 2 times minus 1 is plus 2. At the bottom, I'm going to distribute as well. So x squared times the second, it's going to be x to the 4 plus x to the 3 plus x squared minus all the rest. So that basically it's me using the distributive law a bunch here, or the distributive property. Okay, so at this point now we can gather terms and simplify. What a monster. So gather like terms, this is 3. So we'll do the constants first. 3. And the linear pieces, there and there. Nothing in the other piece. So it's going to be plus 2x. Quadratic pieces, there, there, there. So they cancel out, don't they? I've got an x squared plus an x squared minus 2x squared. So no quadratic piece. Then a cubic piece. Cubic piece is just there, but then it's cancelling again with this. Interesting. Is there a degree 4 piece? No, and there's a degree 5 piece on its own, plus x to the 5. Finally, on the bottom, Same deal. What do we have? Constant, there's just 1 coming from this, but it's a negative, so you've got to be very careful. So -1. Linear piece, just this. Again, minus, minus, so it's going to be a plus. Is that correct? Or have I made a mistake? Nope, I have made a mistake. Classic transcription error. So this to this, right? It should be a plus there. So I made the mistake I made before. Thank goodness we caught it. Okay, so what is it? Well, it's actually a minus x then. Easy to make a mistake like this. This is why you've got to be so careful. Then what? Okay, so now what about square terms? Well, now I've got a plus x squared but a minus x squared, so that doesn't turn up. X cubed there, so it's going to be plus x cubed. And then finally there's a plus x4 at the front. So this is me gathering like terms if you want. So the final answer basically is, well, we could choose P to be equal to the top here and Q to be equal to the bottom. Okay, so that's not an uncommon example, right? That type of algebra needs to be something that you have to be able to do. And doing it, it's a lot of steps, right? So let's just look at what we've got all the way from beginning to end. It's a lot of things. But every stage is one of your elementary properties. This is the reason at the very start I was so careful to kind of go through them incredibly precisely so that we know that what we're using at each stage. So this is a pretty difficult example, absolutely, but every step is elementary. It just requires being careful more than anything else. And this business about from line to line, making sure you're copying things correctly is very important. I myself made an error a moment ago that thankfully was picked up, where I accidentally wrote this as a negative instead of a positive. That would have been a disaster, but thankfully we picked it up. And it's just something you've got to be aware of, and you've got to write it this carefully so that you can spot errors like that. Like I said, if you're not including all of these steps, it's super easy to miss something, and it's very difficult to work out exactly where the problem started. Okay, so let's do another example. All right, so let's find polynomials. Same kind of story. Let's say px and qx exactly as before, such that, well, let's do something a little bit different. Let's do x squared minus 1 divided by, so x squared plus 1 is equal to 2x plus 3 divided by x minus 1 multiplied by, kind of an interesting example, over qx. Okay, and of course, when I'm writing this, I'm making some tacit assumptions. X squared plus 1, x squared is always greater than or equal to 0, so x squared plus 1 can't ever be equal to 0. So I've got no problems with the denominator on the left-hand side. On the right-hand side, of course, we've got to assume that, x minus 1 does not equal 0. So, okay, i.e. x does not equal 1. Okay, so I can't have 1 in this case. Just writing it down to make sure we really understand what's happening. Okay, so let's go through this. I need to somehow rearrange this, essentially, to get px, qx on one side. So what should we do? Well, let's do this. There are quite a lot of ways I could do this, I think. But I think the simplest way, well, I'll do one that basically means, which basically shows you something which can turn up, which is quite tricky to deal with. So let's do the following. Let's invoke the following piece of algebra. So imagine I have C is equal to A times B. Then this would imply that C divided by A, or at least let me write it like this, B is equal to A divided by C. Okay, assuming, oh sorry, B is wrong way around. It's C divided by A, isn't it? So it's a kind of a standard piece of algebra. And of course here, A can't be equal to 0. So, why am I saying that? Well, let's kind of do this. If I was to do this, so maybe I want a bit more space for this. So I'm going to put that there kind of small so it doesn't interfere too much. So this would imply that Px over Qx. Okay, so here's a pretty confusing piece of algebra that can turn up. So this would be equal to a ratio of two fractions, wouldn't it? So like I said, there are different ways to do this, but this one is particularly confusing when you see it, so it's nice to kind of have an example. So 2x plus 3 divided by what? Divided by x minus 1. I suppose here, we are making another bit of an assumption, aren't we? We can't have 2x plus 3 here equal to 0. If it was equal to 0, it would be dividing by 0 again. So, okay, the logic would fail. So I need to be kind of completely away from all of these nasty problem points. So, i.e., x can't be equal to minus 3 divided by 2. Not a big deal. Okay, so next what? Well, what do I know about the ratio of fractions? If I have fractions, the numerator here goes to the denominator at top, and the denominator goes to the numerator on the top. So this would imply, so this is going to be the following principle. This is going to be a divided by b over c divided by d is equal to ad divided by bd. So like I said, there are kind of different ways to do this, but this, when you have a ratio of fractions, it's important you can deal with it. So I've almost said completely the wrong thing. What is it? It's bc on the bottom. It's important you can deal with a ratio of fractions, so that's why I'm doing it in this manner. Okay, so what does that tell you? It tells you that px over qx is equal to what? It's going to be equal to x minus 1 times x squared minus 1, all divided by x squared plus 1, 2x plus 3. And now at this point, well, we can FOIL the top and bottom, which is just the distributive law, and simplify things. And I think what I get is, overall, I get 1 minus x squared plus x cubed. Taking the time there, yep. And on the bottom, a little bit more complicated. You've got to go through this more carefully. It would be 3 plus 2x plus 3x squared plus 2x cubed. Very good. So at this point, what have we got? Well, we're basically done. Now I have my choice of px. Choose this to be px, and choose the bottom to be qx. And maybe just to really hammer home all the details, this is just the distributive property of foiling if you want. Very nice. So this is a kind of a difficult example. You could at the start have done something a little bit different, right? So maybe this is another way to do it. So alternate approach maybe. We could kind of gone a little bit faster through this. Like I said, I did want to just make sure we have some experience dealing with an expression like this because it's kind of confusing looking. But if you have something like a over b is equal to c over d times e, well, you can cross multiply by d and divide through by c and kind of immediately get to the fact that, well, ad divided by bc is equal to e. So I'm multiplying on both sides by d and dividing both sides by c. That's totally reasonable, piece of algebra at the start. It's probably more sensible. It's probably a more elegant way to do it, really. But as I said, this is something you will see turn up occasionally, and you've got to be confident about how to deal with it. So that's the reason I've gone through this carefully. Okay, so another example. So all these are examples that certainly turn up in first year lower division mathematics classes. So find polynomials again. Find polynomials, let's say px and qx, such that the following is true. Let's say px over qx. So we'll do one that is pretty unpleasant looking. Let's do x divided by x plus 1 minus x squared divided by x cubed plus 2. All of that divided by x minus 1 on the bottom. Right. So I want you to turn this basically into a rational expression. Now, this is a good example of a bridge too far for lots of people. There's so many things to deal with. It's like, what do you do first? There's no one way to do this. There's many ways to deploy your basic rules, but here's a very swift way to do it, which always works. First of all, the ratio is terribly confusing. So it's good to turn that into a product, I think, straight out the gate. So this, of course, is equal to x over x plus 1 minus x squared divided by x cubed plus 2 multiplied by 1 over x minus 1. I'm kind of going a bit overboard with the brackets, but no problems there. So what's this? This is me literally just writing the definition of a ratio down. Now, the reason that's good is because multiplying fractions is easier. So next, what are we going to do? Well, we need to combine the thing in the brackets, right? So in the parentheses, that has to happen first. So this is going to be equal to what? So we're going to have to do the usual combination of fractions. So this would be equal to x times x cubed plus 2 minus x squared x plus 1, all divided by the product. Let's try and keep this reasonably neat. Times 1 divided by x minus 1. So again, what have I just done? It's the following piece of algebra. It's just when I take a difference of two fractions. So a over b, minus c over d. That's equal to AD minus BC divided by BD. So that's the property I'm using. Whew. So now at this stage, this can all be brought into kind of basically one expression, pretty much. This is going to be brought into the expression. Okay, so I'm multiplying. I just multiply tops and bottoms. It's nice and simple. So this is going to be x times x cubed plus 2 minus x squared x plus 1. So I'm not doing that yet. I don't want to overload things. Then x minus 1, x plus 1, x cubed plus 2. So again, what's that really using? That's using the property that, so I'm going to do exactly the same, a divided by b times 1 over c. A times 1 is a divided by bc. That's what I'm using. And now if I take the time to multiply everything out, and sometimes you don't want to, remember, multiply out the denominator. Sometimes it's a good idea to leave it as a factored format, but I'm going to take the time to do it. The top, it's what? Are there any constant terms? No. Any linear terms? Yes. 1 coming from the product of those two. So 2x. Any quadratic terms? 1 coming from these two, so it's going to be minus x squared. Any cubic terms? Yes, from those two. that correct? Yes. So this is going to be minus x cubed. Any other terms? Yes. The product of those two is x to the 4. And the bottom, of course, will be much more work. I would need to go through quite a complicated procedure to do this, but when you finally do it, I'm not going to go through every detail here. After a good deal of work, because you need to multiply things out. So this is basically a repeated application of, as always, the distributive property. That's a pretty difficult example, I think, because it requires doing things very slowly, and there are different ways to do it with absolute certainty, but this is a way which I think is very effective, and it should be something you kind of go through carefully yourself. You will see lots of examples like this in the early stages of calculus courses, for example, and yeah, you need to be able to do this. So I want to do one last example, which is a little bit of a warning. So something that looks fairly innocuous. So let's find all x such that 1 over, so let's do something nice, x minus 2 plus 1 over x plus 2 is equal to something simple, 4 divided by this, x minus 2, x plus 2. Okay. So first of all, that does look like a pretty tricky problem, because how am I going to do this? An instinct that I'm sure many of you have when trying to solve these is to try to solve for x, which basically means rearrange this using your laws of algebra until there's a number on one side and x is on the other. This is a terrible plan here, because this is far too complicated, right? It's a nasty expression. The term on the bottom on the right hand side is a quadratic expression, right? It's going to be horrendous to try to unravel that, let alone the fact it's occurring in the denominator of something. So you shouldn't always say to yourself, oh, I need to solve for x every situation like this. You need to think, well, what properties have to be satisfied for these two to be equal? So let's just remind ourselves the following. First, we know the following. Kind of one of our core properties, a over b is equal to c over b. This is if and only if a is equal to c. Here we're assuming b is non-zero, of course. That's kind of the cancellation property, really. Just multiply through by b. So we need really to write the left-hand side and right-hand side down as fractions where the denominators are the same, and then all we've got to do is compare the numerators. So let's make the numerators also, so let's make the denominators equal. Now, thankfully, it's not too hard how to do this, right? We can see that the left-hand side, I can just combine it as a fraction, right? So this is going to be equal to 1 times x plus 2 plus 1 times x minus 2 divided by the product. And there's no need to multiply out the product. Okay, so this, I want to be very careful again, as always, this is just the fact that a divided by b plus c divided by d is ad plus bc divided by bd. So now let's take the time to simplify the numerator, or at least write it in more polynomial format. So doing this, constant term, I get a 2 there, but I get a minus 2 from that, so it's 0 constant term. Linear term, I get an x plus an x, so I get a 2x on top, all divided by x minus 2, x plus 2. All right, so let's take a moment. This is equal to this. So what I'm really doing is the following. this expression, this statement at the top, so this is now, of course, if and only if this expression is equal to this expression. They have to be equal to each other. Okay, and it's perfect. The way it's been set up, the denominators are exactly the same, so the only way this can happen is if the numerators are equal to each other. So this forces what? 2x must be equal to 4. And what would this force? This would force x to be equal to 4 divided by 2, of course, which is equal to 2. So at this point, all is good. I'm happy. I say to myself, the answer is 2. So why is that not correct? What have I done wrong here? So I'll give you a moment to look at it. What's gone wrong? Why is that not correct? So it's quite subtle. The reason it's wrong is at the top here. For this to be valid, you need the denominator b to be non-zero. Doesn't make sense. However, if I was to choose x is equal to 2, that would make the denominators 0. So these expressions wouldn't make any sense at all. So this is an example of something called an extraneous solution, where the algebra basically leads you down the garden path. So this is a really big warning. So if I was to conclude x is equal to 2, I'd have forgotten really the meaning of what I'm doing. So warning. It's a cool example. X equals 2 is not possible. As x minus 2 equals 0, and we'd be dividing through by 0. So what's the answer to this? Well, basically the answer is there are no solutions. The only potential solution was 2, and it can't possibly work because I'd end up dividing by 0. So the conclusion is, maybe not the conclusion, but I'll say, hence there are no solutions. Really interesting example. And I think there is a moral to this. And the moral is something I've said quite a few times. When you're doing algebra with things, you're dealing with numbers. I mean, you may be dealing with letters, but they're stand-ins for numbers. They're variables, right? They represent numbers. And you've got to be careful because they may, for certain numbers, not make any sense. And this is a classic example. These expressions do not make sense for x is equal to 2. So the conclusion really is the following. And this is kind of true across the board for everything you ever do with algebra. Don't just apply the algebraic rules blindly. Apply. Don't just blindly apply algebra. Don't say, just remember that it has to represent numbers. Remember, you're always dealing with numbers. So if you come into a conclusion using algebra, take a moment, take a breath at the end and ask yourself, well, is this actually meaningful? Is there a reason that this is precluded? Is there some step I've done which isn't reasonable? And the step that's not reasonable basically is, it's essentially this problem here. When you're writing this down, you are implicitly assuming x is not equal to 2, because you can't possibly have anything divided by 0. Same, you're assuming as well that x is not equal to minus 2, right? Because you again can't divide through by 0. So with these types of expressions, be very careful. This is quite a sophisticated comment. But remember, when you're doing algebra, you're dealing with numbers, and you can't just do anything you want with numbers, right? You can't divide through by 0, for example, or take square roots of negatives.